Hello, welcome to Econometrics Melody. In this tutorial, we'll deal with the commands data signature, type, and nodes. These commands are very useful. Let's begin with this main Stata interface active each time. Press Ctrl 8 for activating data editor and Ctrl 9 for activating to file. Let us prepare our data set and save it with the appropriate name. So our data set, it contains 4 variables. Some of the observations are missing in each variables. Now let us see some of the file handling commands before we begin into our tutorial of data signature, type, and nodes. So pwd, this means present working directory. This will show you the present working directory information. So this is the path, and if you want to change it to something else, in this case D drive, so now our present working directory is our D drive, and we have changed the present working directory by using the command called cd. Now let us change this present working directory from D drive to its original to this path. Now our present working directory is this path. Now if we type dir, this will display all the directories. So we have these files or folders in this directory. Now let us see here, do we have any folder called water? We don't have any folder called water. Now let us make the folder or the directory. So the command to make any directory is mkdir. So let us make a directory called water, and let us check whether it is there or not. So do we have water? Yes, this is the directory that we have created. Now let us change our directory to this folder. So this is the path. We have added this water to our previous working directory using the command cd. This is change directory, the full form. Now if we see what are the folders within this folder water, so is this folder is we have created just now, there are not any folders, so we don't see the list of files or folders. So our present working directory is this water. Now let us remove the directory. So we are in this directory water, and we cannot remove it, the water itself, right? We'll have to just go one step back to it. So let us go to our directory, which is just one step. In this directory we have water, the folder called water. Now we can remove this directory called water by using the command remove dir. Now if we check this, we should not have any directory or folder called water. Now let us use another useful command, that is copy. We can copy the files. So how does this work? Copy, this is the source file, you need to copy this to this. Okay, this is the destination, the second one is destination, and it is a text file, and if this destination already exists by this name, we need to replace it. So this is very intuitive command. See, we have copied the first file to the second one. Now let us copy another, this data, this data signature data with wd signature data, and replace it. So we have copied two. Now in case of the source, if our host is on the file is in our net, then we can copy this using the same command, following the same pattern. This is the source which we'll have to serve in our internet, and we want to copy it by this name and replace. But this is not going to work right now because I don't have a net facility here. So if you list the name of the files, we should get this wlrb.txt and wdsig.dta. So wlrb.txt and wdsig.dta. So this is the result after computation it. Now let us remove this data and text that we have created using this command called erase. So this is very simple. We write the command followed by the file that you want to erase. So once we erase this, let us erase this, and if I type list the directories, we should not get these files. So we don't have wd, anything from wd, neither do we have anything from wl. So we have erased this. Checksum, it creates the values based on the observation and the variables, checksum of the file. So this is our data. So this is the checksum. This is very useful in creating our data signature. Now let us use our command called type. This will display the contents of a file. So this is the file dsig data signature data, and let us display its content. And age, the option age is asis is age is. So this is the result you get, and actually I don't know how to interpret this result. Now let us use another option called ages for a smcl file. Smcl is the log file, so let us use the command ages and we get this information displayed. And let us use another option for the same file, smcl. So we get this. If we specify smcl for this, these are the log files, so you get the information of the log files over here. Now let us try the other one. So this is the result, and you can interpret it. So star bang, this is useful only when the text, it begins with asterisk and exclamation. And let us execute. What does this do file contain in it? Factor error correction model practice. What are the commands these files contain? So these are the contents. So to understand the command type, actually it displays the contents of a file. This is a very simple one. Now let us go to the next command called data signature. And data signature, it is very useful in data validation and to check whether the data had changed or not. Now let us list our variables. These are the variables, and they have the missing values as well, a, b, c, d. So let us use the data signature data that we have saved earlier. So this is the same one, and if we write here list, we'll see the results. So these are the same data. Now you need to specify data signature to actually provide a signature to this data, and the signature, the initial two letters, these are the number of observations followed by the number of variables, and these are the checksums, or they are created according to the number of data and its values and so on. Now let us again set our data signature, and data signature, you see this display data signature, and this data signature has been set. And let us save this and replace if we have saved the data signature earlier. Now periodically after a certain time, you need to type this data signature confirm time and again to see whether the data had changed or not. And here data unchanged since this time. So after an hour or two, you can again type this and check whether the data has changed significantly. So actually we have not changed the data value. So data unchanged since this time. Okay. Now let us try to make some changes. So these are the changes that we are going to make, and we have already set the data signature, we have already set. Now let us check whether what does it display. So data signature confirm and is strict. Let us see what does it display. So data have changed since this time. Okay, so if you want to see what are the changes, you will have to specify data signature report, and these are the reports. So it says original number of variables, and there are 4, and it specifies values have changed. Yes, we have changed the value. And added variables 1, we have added this variable called e. Drop variables, we have not dropped any variables. So this data signature does not report the labeling of the data or variable. So this is a very good way of checking whether our data had changed or not. Now let us again set this data signature. Now this is our beginning. Now we have set our data signature. The initializer is again the number of variables, sorry, the number of observations followed by the number of variables, and these are the results of checksum. Now let us save this data signature set, and we reset this again, and we save this, the data that we have right now in our memory, using by the file name called original. Okay, so let us run this command. So file original data sig already exists, so why don't we erase this from our memory? Let us erase this. Now it should not exist. Now let again understand this command. We are going to set the data signature, and then we want to reset it Okay, this is our new beginning, and we want to save this data in the file in the memory using this file name called original. So let us save this data signature file, original datasig. On this name the file will be saved. 27 observation, 5 variables, and so on. Now let us make some changes. Okay, maybe after saving this data, the original data, you keep the original copy and you send the same copy to your friends, and then again they make certain changes and then they will give it back to you, and then you can check what are the changes they have made. So let us make the changes. Okay, or your friend is making these changes, dropping the variable and so on. Now let us write certain nodes as well. Again, data signature does not capture the change in nodes and levels. Now let us check confirm. Okay, now you get this data, from your friend, and you have its original version saved in the name original.datasignature. Now let us check data signature confirm using this original, and you see data have changed. This alerts you data have changed since this time. Okay, and again let us run this command. You get the same result, and you want the report. Okay, what are the changes your friends might have made? Okay, your friends values may have changed. Original number of variables 5. Okay, so your friends have changed this. Added variables, so these are the information on added variables. They have actually renamed the variables, and drop variables is 2. So if you create a checksum of this, so this is the checksum of DTA SIG data. This is our original data, and this is the number. Now if you share checksum, there is a difference, right? So this also indicates the changes. 3524691 and 2564381. This is for the original data. And if you see the data signature that we have said, do we get this number? Do we encounter this number? Maybe not now. Okay, it does not matter. Now if you are really very interested on understanding what are the compositions, how do we get this number? So actually data signature, it contains of number of observations followed by number of variables, and checksum function of variable names and checksum function of the values of the variables. So they are calculated in 2 different ways. Now let us go to our next option. This is to place some nodes. So let us display what are the nodes existing for our variables or data. So this data that is in our memory, so it carries the node called practice of data signature. Okay, it's fine. And the variable f, we have other variables as well, but the variable f, it carries the nodes. New variable generated, we need this variable. Okay, now let us add some node. Okay, nodes, and if you don't specify anything, this node will be tagged to the data. So nodes, we have written data signature practice, and let us write again nodes. Now we will have 2 nodes, practice of data signature and data signature practice for the data. If you don't specify anything over here, so this node is for the data. Now let us add some nodes to the variable f. So we have 2 nodes already, so if we add all 3 nodes, we'll have 5 nodes in total. And if you list it, data will have 2 nodes and the variable f is going to have 5 nodes. Now you can display the specific node number. So we are going to list the second nodes for both variable and data. So this is the second node for data and the second node for the variable. And if you specify the variable name, this will specify the node, display the nodes 1 and 2, first 2 nodes for variable f. And you can search the nodes with any word. So what are the nodes in both data and variables that contains OK? So the second node contains the word called OK, and in variable f we have the node number 4 and 5 that contains the word called OK. Now let us again write nodes to display all of the nodes, and let us delete, replace. Okay, we can replace also the second nodes in variable f should be displayed, replaced by we need this variable cleaned. Now we need this variable only. So let us clean this and display this, and you will see we need this variable cleaned. So you can replace the node also by its number. Now let us drop second and third node in variable f, and if you specify nodes, so the numbering, there is a problem in numbering, so we have 1, second and third we have deleted, so we have fourth and fifth number node. Let us add a few more nodes to variable f and let us display it. So the next node will be numbered from 6 to 7, and if you want to correct this, you should specify the syntax called nodes renumber and variable f. Now if you display the nodes of variable f, you will have the numbers in sequence. Okay, now let us again write node f, add something, thank you, and then you see now the number is 6. This is added on the 6th number. Now if you want to display the time, so t capital ES, this is the inbuilt command, ts in the nodes. If you write ts, this will display you the time. So nodes, we have not specified any variable, so this node is attached to the data. So for nodes f, we have ts over here, and cmd, this will make the word called f bold. So let us execute this all and understand this. So how did we get this time? Node number 3 for data, so 12 April, this date, so this is due to this ts. Okay, and for f, we have ts as well in variable f. Where is the date? This is the date, and you see completed date and time. And in variable f again we have variable f. F is displayed in bold. You see variable f, this is displayed in bold. And for data, bold letter, so thank you should be bold in, it is due to this curly bracket and cmd command. Okay, anything following this will be displayed in bold. Now let us, before we leave, let us say two very useful commands. Edit, if you write edit, you can change anything over here. You can edit, let's say I write 12 or maybe 12 over here, and then 9 over here. It's already 912. You can edit the observations values. Okay, but if you write browse, you can only browse, you can see it, but you cannot change this. Now let us see, they are not activated. Whatever number of times I press it, and if I write any numbers, we don't edit, we cannot edit. Okay, so this is the difference between browse and edit. Edit, we can edit the data as in memory, its observation. Browse, we can simply surf it and we can see the values. This is it for this tutorial. Thank you very much for your time. Thank you very much. Econometrics Melody.